I'm Joe Griffin. I'm a hydrogeologist. I spend a lot of time out in the field, and I work on streams and I work on groundwater. And more specifically, I'm here in Butte, Montana, where I've spent the last 30 years of my career looking at environmental damage from the mine here in Butte. Butte is the richest hill on earth, and the mining has gone on for quite a bit over 100 years now. Mining has impacted the entire stream system here, and we're going to take a look at some of that. So here we are on Blacktail Creek. This is one of the streams I've studied, trying to look at the impacts of mining. What's going on with a river? Most people, of course, understand that it is water moving along a channel. But as a geologist, I see it as quite a bit more than that. So one thing geologists do is we look at things that happen through long periods of time. So when I look around and I see this stream, and I know I'm in a mountain valley, one thing I'm thinking about is that mountainside over there is being eroded, and that means that water's breaking down the solid rock there, and it's starting to move it down the mountainside. It finally gets into a stream channel, and it moves it along the stream channel. If you look down here in where I'm standing, obviously there's this muck, there's these clouds of stuff that are coming up where I step on the bottom, and that is probably silt. So we're looking at size fractions, right? So one thing I know is, although it may look fairly clear over here, and it may look sort of cloudy right there, that water over there that looks clear actually probably has some silt being carried along in it. So I want you to imagine now we're shrinking ever so much. Now we can see individual clay particles. Now we're going to shrink even farther. So how far down would we have to go? What's the smallest thing you can think of? If you're thinking atoms or molecules, you're right, that's the next level. Are there actually atoms or molecules in this river? Is that part of what's getting moved? For my job, really it was what has been added to this stream by mining that makes it a problem, makes it an environmental problem. There's certain things that enter this water from mining that are toxic to fish. And it's toxic to the little organisms that live in the stream, like the macroinvertebrates, all those bugs that live in the stream bed. I have here a piece of granite in my hand. Solid granite is something that it's really, really hard rock. This, after it's been weathered, I can now take and start to break chunks off of it. Once the weather starts acting on them, and it may be that it's just, the rainfall is just a little bit acidic, and it starts to actually dissolve rock. So we dissolve these minerals in water, and they become individual atoms with an electric charge. The positive ones are called cations, the negative ones are called anions. So what happens when we take some of this water and evaporate it, and the minerals are left? That's exactly what happens, is you form minerals with ionic bonds, in other words ions again, that are just held together by those electromagnetic forces. And so we're going to look at that, because this is one way I can get some idea of how much rock is now dissolved in Blacktail Creek. I have this instrument here. This is called a conductivity meter. And let's look. So I have a little screen that'll tell me what the readings are, but let's look at the sonde itself to see how it works. So we have a slot, and in the middle of the slot is a little steel post. And what this is trying to do is conduct a current between that little silvery post and the walls of the slot. So I'm going to walk down to Blacktail Creek and grab a sample of water. Okay, so looks pretty clear. There's probably maybe a little bit of clay particles suspended in there, so it's not perfectly clear. And there's really no electricity that can get conducted through the air. So 0.9, or it's now reading 1, is a background reading. It's really, think of it as a 0. So now we're going to put my probe in here. So we're reading 271 microsiemens per centimeter. We're not going to get too hung up on what those units mean, but it's the amount of electricity that can be conducted through this water. So let's see what that means. Let's get some reference to what we're doing. So I have here some water that I bought at the grocery store. This is called distilled water. Does anybody know what distilling does? They take water, they boil it, and the steam comes off of the boiling water, and then you recapture that steam and turn it back into water. Is what you're doing is you're leaving behind almost all of those minerals. All of those ions are left behind. So now we have distilled water, and we have the probe reading 1.1 in just air. Let's see what it reads when I put it in the distilled water. So it goes up to 2.5. So maybe there's a little bit of dissolved ions in there. Not a whole lot. So what we have in the water is between 1.5 and 2, which is far lower than the more than 250 we had in the stream. You may know this as simple table salt, but as halite, I think of this as a rock that just dissolves very, very quickly, as we all know. So I have a rock that's going to dissolve real quickly. We're just going to simply dissolve it into this water. We had distilled water reading about 1. We had stream water reading about 270. And in this case, you actually can see how much rock dissolves in water to give us a reading of 1,840. Well, I hope sometime in the near future we can all get out on the stream side to do some of these same experiments